This is Math 2, Worksheet 8.5 Notes. And basically we are talking about rational or irrational numbers. Rational versus irrational numbers. Now, hopefully you remember that a rational number is any number that can be written as the ratio or fraction of two integers. For instance, something very basic, 2/3 is a rational number, as well as negative 2/3 is a rational number because they are both fractions or ratios with using integers. Negative 2 is obviously a negative integer. The whole number 5 is a rational number because it can be rewritten as 5/1. Same thing with negative 7. It can be rewritten as negative 7/1 or even negative 7/1. These are all examples of rational numbers. Several decimals are also rational numbers because we could take 0.75 and we could rewrite it as 3/4, which is a rational number. The fractions that are, the decimals that are not rational numbers are decimals that never repeat and never end. So if we take, you remember the number pi is 3.14, and then it goes on forever and ever, and it never repeats and never ends. So that is an irrational number. Okay, well, more specific to what we're talking about today, or this unit, is radicals. Okay, like the square root of 2. Radicals that we cannot simplify are considered irrational numbers. We can get an estimate of what their number is, but we do not have an actual number. I believe if we take the square root of 2 and put it in our calculator, it comes out to be approximately, we put this little like that to mean approximately 1.41, and again it goes on forever without repeating. So this is an irrational number. So anytime we have an answer that we come up with that we cannot simplify the radical, it is considered an irrational number. So let's take a look at worksheet 8.5 and let's simplify some of these expressions and then decide whether they're rational or irrational. Okay, looking at number 1, we're adding fractions. Remember, if we're add, we have to have the same denominator. So I'm going to multiply top and bottom by 5, and we get negative 5/20 plus, we're going to multiply top and bottom by 4 and get 8/20. Now we have the same denominator, so we can add. Negative 5 plus 8 is 3/20, and that is a rational number. Okay, moving on to number 3, we have 5√13 minus 7√13, which is negative 2√13, which of course is an irrational number because we have that square root 13. Okay, moving on to number 5. Well, because these two parentheses have nothing out in front of it and it's positive, we can just pretend they're not there. So basically 3 plus 4 is 7, and 6√17 plus 2√17 is 8√17. And of course that is an irrational number because we have a radical in the answer. All right, now moving on to number 7, we've got to do some work there. So 3 plus 7√2. Now negative times a negative is a positive 5, and negative times a positive is a negative 7√2. So 3 plus 5 is 8, and 7√2 minus 7√2 is 0. They basically cancel each other out. So our final answer is 8, and that is a rational number. So there's an example of where we have irrationals in our problem, but we end up with a rational answer. Okay. Let's move on to number 9. So again, we need a common denominator. We're multiplying here, so we don't need a common denominator. So we can simply multiply across and get negative 3 times 4 is negative 12 over negative 45, over 5 times 9, which is 45, and reduce. 3 goes into negative 12 negative 4 times, and 3 goes into 45 15 times. Of course, if you're good, we can always cross cancel. 3 goes into 3 once, 3 goes into 9 3 times, and then negative 1 times 4 is negative 4, and 5 times 3 is 15, and of course that is a rational number. Moving on to number 11. All right, 5 times 3, we think of these as coefficients. We multiply what's in front. 5 times 2 is 10, and the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3, so 3 times 10 is 30. We could think of it this way as well. 5 times 2 is 10, and the square root of 3 times the square root of 3 is, of course, 3. When you multiply two identical radicals, you get what's underneath. Either way, we end up with 30. Moving on. 4 times 2 is 8, and then we end up with the square root of 12 times the square root of 3. Well, I'm going to break down 12 to 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. And, of course, we have this 3 from the other radical. It's square root, so, of course, we're looking for pairs. This 2 gets out, this 2 gets killed. This 3 gets out, this 3 gets killed. So we have a 2 and a 3 getting out. 2 times 3 is 6, and 6 times 8 is 48. And, of course, that's a rational number. Moving on. Number 15, 3 times 6 is 18, times the square root of 7 times 14, but let's break 14 down to 7 times 2. Looking for pairs, a 7 gets out, a 7 gets killed, and the 2 stays in. 7 times 18 is 126, square root 2, which is irrational. Okay, last one. I'm going to take this and change this to 7 times the square root of 75 over 3. Remember, when you have a square root on top and bottom, you can put them under the same roof, as I like to say. Why would I do that? Because this becomes 7 times the square root of 25. 75 divided by 3 is 25. And, of course, the square root of 25 is 5. So this becomes 7 times 5, which is 35. And that is a rational number. All right, so we're going to leave it right there for now. All right, so let's actually jump in here and continue doing the odds. What can you say about the sum of any two rational numbers? Well, I think we can say that the sum of any two rational numbers is going to be a rational number. You add two rational numbers together, you're going to get two rationals. Okay? I'll leave 20 for you guys to think about. Let's go over 21. What can you say about the product of any two rational numbers? Okay, the product of any two rational numbers are going to be rational numbers. You're not going to multiply two rationals together and end up with an irrational. I'll leave 22 for you. Got to think about those, though. 23, can the sum of two irrational numbers be rational? Okay, and boy, I haven't thought about this one in a while, and you cannot take two rational numbers and come up with a rational number, so that would be no. Let's think about that one a little longer, but I do not, I'm almost positive saying no. And number 24, again, you guys are going to think a little harder on that one. All right, number 19. From the numbers 5, 6, 2, root 6, to minus root 6, square root 5, square root 6, choose two numbers. When you multiply them, the answer is rational. Well, let's just pick an easy one. Let's just pick 5 times 6. You get 30. Rational number. Multiply them, and the answer is irrational. Well, how about the square root of 5 times the square root of 6 gives you the square root of 30. Add them, and the answer is rational. Well, we better stick with two rationals. 5 plus 6 is 11. And finally, add them and the answer is irrational. Let's just go with the square root of 5 plus the square root of 6, which is just the square root of 5 plus the square root of 6. We can't put those two together. All right, 26 through 29, we have to do some simplifying, and then we have to decide if it matches up to this. So first thing we should probably do is simplify this. So we have 16 to the 3/4, which is 16 times 16 times 16, right? Well, there are 4 2's in every 16, so it looks like 3 2's are getting out, which is 8. So far, so good. And then x to the 5/4. So 2 times 2 times 2 is 8, and x to the 5/4. So yes, number 26 is good. All right, I'm going to leave 27 for you to do because I kind of messed up and did an even one there. And I'm going to do 29. All right, so the 4th root of 8, well, that guy cannot be simplified. The 4th root of 8 is, if I simplified this guy, it would be the 4th root of, x times the 4th root of 8x. These two are not the same, so we are a no there. I'll leave 27 and 28 for you to do. All right, thanks for playing along.